Sketch a unit circle indicating the reference angles 30 degrees, 45 degrees, and 60 degrees in each quadrant. Label each angle in both degrees and radians. So let's start by sketching a circle. You want to keep it quite large. There will be lots of information added to this. Then we add axes. There's the x-axis. It's the wrong one. Like that. There's the y-axis. Okay. So let's start by putting in the degrees. We're going to put the degrees in blue color on the, we're going to try to fit them on the inside of the circle. So we have 0 degrees right there, 90 degrees up here, 180 degrees, 270 degrees, and 360 degrees. Then they want us to add their reference angles 30, 45, and 60 degrees in each quadrant. So remember that a reference angle is the angle from the horizontal axis, from the x-axis, either going up or going down. So that means that we'll have to eyeball it here. So something like that. That will be 30 degrees. So this angle here is 30 degrees. And on the other side here, this terminal arm here is going to be 180 plus 30 degrees. So it'll be 210 degrees. So that angle is going all the way from here like that. That's 210 degrees. There is also the reference angle 30 degrees on this side, like this. So this angle down here is going to be 360 degrees minus 30. So that's 330 degrees. This angle here, like that, is going to be 180 degrees minus 30 because we're going counterclockwise here. So it's going to be 150 degrees. So if we put in the 4 30-degree reference angles that are present in the unit cycle, 1 in each quadrant. Next, let's put in, we can put in the 45-degree angle. So that's going to be right in the middle of the quadrant. So, oh, I'm supposed to use a line. Hold on. Wrong tool, like this. So that means that this here will be 45 degrees. This angle like that, all the way there, is going to be 180 degrees plus 45 degrees, which is going to be 225 degrees. Then we also have the 45-degree reference angles in quadrant 2 and 4, which is going to be something like this. So this angle here is going to be, we can either do 90 degrees plus 45 or 180 minus 45. So we're going to get 135 degrees. Down here, this angle here, so if I indicate it, so we're looking at now this angle all the way to there. That's going to be 360 degrees minus 45 degrees. So it's going to be 315 degrees. And then finally we have the 60-degree angles, the 60-degree reference angles, which are going to be, hold on, let me put in all of them at the same time. So here's in quadrant 2 and 4, and this is in quadrant 1 and 3. So this angle like that is going to be 60 degrees. This angle here is going to be 90 plus 30, so 120 degrees. This angle here is going to be, we can either do 270 minus 30, or we can do 180 plus 60. So it's going to be 240 degrees. And finally, this angle right here, we can do 360 minus 60 degrees. So it's going to be 300 degrees. So now we have the unit cycle labeled with, or labeled in degrees. Now we're going to label it in radians. We're going to put the radians on the outside of the circle in green. So at the beginning here we have 0 radians. 1 full revolution corresponds to 2 pi radians. And that means that 180 degrees will be half of the 2 pi, so this is just pi. This 90-degree angle corresponds to pi divided by 2. And the 270-degree angle, we're going to have 3 pi over 2. Hold on. So it's 3 pi over 2. Okay. So pi over 2, that corresponds to the 90-degree angle. The 30-degree angle is a third of 90 degrees. So that's going to be pi over 6 in radians. The other 30-degree reference angle, the one that's where the terminal arm is 150 degrees, that's going to be 5 pi over 6. So, and the way we can get that is we can take pi, actually I can write it here, pi, and subtract pi over 6, which equals 5 pi over 6. Should be right there. So to determine the rest of the angles, specifically quadrant 2, 3, and 4, we can use the reference angles that we have in radians, and we can either add or subtract from the pi or 2 pi to get the rest of the angles. So if 30 degrees is pi over 6, because it's a third of pi over 2, then 45 degrees, well, that's half of pi over 2, which means it's going to be pi over 4. And then 60 degrees is double of 30 degrees, so it's going to be double of pi over 6, which is going to be 2 pi over 6, or 1 pi over 3 if you reduce that. Okay, so let's complete the rest of the quadrants, and I'm going to show you the math here so you know how you can determine those other angles. So we already did 5 pi over 6. Let's do the 135 degree angle. So that's going to be pi minus pi over 4. And that's going to be 3 pi over 4. So that's right there. 120 degrees, so that's going to be pi over 2 plus pi over 6. So 90 degrees plus 30 degrees. So pi over 2 plus pi over 6. That's going to be 4 pi over 6, which can be reduced to 2 pi over 3. We are looking at the 210 degree angle. Well, this is just going to be the pi, 180 degrees, plus 30 degrees. So pi plus pi over 6. Which is going to be 7 pi over 6. Like that. 225 degrees is going to be pi plus pi over 4, which is going to be 5 pi over 4. The 240 degrees is going to be, we can use the 3 pi over 2 and subtract 30 degrees from 270. So 3 pi over 2 minus pi over 6. So that's going to be 8 pi over 8 pi over 6. Am I doing this right? I can write it out. I can do, we have 6 in the denominator. So it's going to be 9 pi minus pi. So that's going to be 8 pi over 6, which we can reduce to 4 pi over 3. That corresponds to 240 degrees. And then we have the last quadrant, quadrant 4 here, to the 330 degrees. Well, that's going to be 2 pi minus pi over 6. Okay, so it's going to be 11 pi over 6. The 315 degrees, we're going to take 2 pi. We're going to subtract pi over 4. That's going to be 7 pi over 4. And then finally 300 degrees. We can take this here, the 3 pi over 2. And we can add pi over 6 to that. So it's going to be 10 pi over 6, which can be reduced to 5 pi over 3.